Hello guys, my name is Bino, and in this video we'll be going through question 1 from July 27th 2021 and for mathematics question paper. Question 1.1, we have to integrate the following expression. So before we can integrate, let's try to simplify this integral. So this will be equals to the integral of 2 multiplied by 1 over x minus 7 multiplied by 1 over sin squared x plus 4 times pi to the power 3x minus 4 over 3 multiplied by e to the power negative 4x plus 1 over cos x cot x plus 7 over 8 pi dx. So this will be equals to the integral of 2 multiplied by, so we know that 1 over sin x is equals to cosec x. So in the place of this 1 over sin x, we will write cosec x, and 1 over tan x is equals to cot x. So in the place of this 1 over tan x, we substitute cot x minus 7 over, so we have 1 over sin squared x. So 1 over sin x is equals to, and 1 over sin squared x will be equals to cosec squared x. So in the place of that 1 over sin squared x, we write cosec squared x plus 4 multiplied by pi to the power 3x minus 4 over 3 e to the power negative 4x. We know that 1 over cos x is equal to sec x. So we write plus, so in the place of that 1 over cos x, we write sec x, and 1 over cot x is equal to tan x. So in the place of that 1 over cot x, we write tan of x plus 7 over 8 pi dx. So from here we are at liberty to integrate. So the integral of cosec cot x according to the formula sheet is equal to negative cosec x minus 7. The integral of cosec squared x, also available on the formula sheet, is equal to negative cot x plus 4. So the integral of pi to the power 3x, so if we had a to the power bx, the integral will be equals to a to the power bx divided by b multiplied by ln of a. So in this case, the integral of pi to the power 3x will be equals to pi to the power 3x divided by 3 ln of pi. So if we were differentiating, we were going to multiply by 3 ln pi, but now that we are integrating, we are dividing by 3 ln pi. So we have negative 4 over 3. The integral of e to the power negative 3x is equals to, so we use the same formula, e to the power negative 4x divided by negative 4 multiplied by ln e, but ln e is equals to 1, so there is no need for us to go and write ln. So in this case we wrote ln pi, but in this case we will write ln e, but ln e is equals to 1, so there is no need for us to express it here, plus the integral of sec tan x is equals to sec x, also available on the formula sheet, plus the integral of 7 over 8 pi is equals to 7 over 8 pi x plus c. So we can simplify this. So this will be equals to negative 2 cosec x, negative multiplied by negative is positive 7 cot x plus 4 pi to the power 3x divided by 3 ln of pi. This negative 4 will cancel out with that negative 4, so we'll be left with e to the power negative 4x divided by 3 plus sec x plus 7 over 8 pi x plus c. And this will be our answer for question 1.1. Question 1.2, we have to simplify and integrate the following integral. So we have the integral of 7 cos x multiplied by sin x plus 9, all of which is divided by cos squared x. So if we had a plus b over c, this will be equals to a over c plus b over c. So in the same token, we can express this as 7 cos x multiplied by sin x divided by cos squared x plus 9 over cos squared x dx. So we have 7 cos x multiplied by sin x. So we can break down the cos squared x and write it as cos x multiplied by cos x plus 9 over cos squared x dx. So that cos x will cancel with one of the cos x in the denominator, and we'll be left with 7 multiplied by sin x over cos x plus 9 over cos squared x dx. So we know that sin x over cos x is equal to tan x, and that 1 over cos x is equal to sec x, and 1 over cos squared x will be equal to sec squared x. So we have 9 multiplied by 1 over cos squared x, which we can express as sec squared x dx. So the integral of tan x is equal to negative ln of cos x. It's available on our formula sheet, plus 9 multiplied by the integral of sec squared x, which is equal to tan x, plus our constant c. So this will be equal to negative 7 ln of cos x plus 9 times tan x plus c. In the memorandum, they have cos squared x instead of cos x, like the way that they have on the question paper. So if this was cos squared x like in the memorandum, this cos squared x was going to cancel out with that cos squared x, and we'll be left with 7 multiplied by sin x, and the integral of sin x is equal to negative cos x. So we are going to have negative cos x plus 9 tan x plus c as our final answer if we had the square there. Question 1.3.1, we have to sketch and clearly indicate the area enclosed by the graph y is equal to 2 to the power ex, the x-axis, and the coordinates x is equal to -1 and x is equal to. We also have to show the representative strip used to calculate the area. So we have the graph of 2 multiplied by e to the power x. So let's say that when x is equal to 0, then y is equal to 2. So we already know that our graph is going to cut the y-axis at y is equal to 2. And when x is equal to 1, so when x is equal to 1, this will be around 5,436, and when x is equal to 2, this will be somewhere around there. So we can say it's going to be somewhere around 14,778. So let's move to the negative side. So when x is equal to -1, so when x is equal to -1, then y will be equals to 0,7357. So when x is equals to -2, then y will be equals to 0,27 graph will not cross to the negative side of the y-axis. It will always be on the upper side of the positive y-axis. So we can draw this graph. So this graph should take that form. And we have to sketch and indicate the area from x is equals to -1. So x is equals to -1 is there, and x is equals to +1. So x is equals to +1, it's somewhere around there. And we also have to show the representative strip used to calculate the area. We can draw our strip vertically. So this will be our strip, which will be used to calculate the area. So we have delta x, and delta x is equivalent to dx. So when we calculate our area, we have to use that dx. So question 1.3.2, calculate using integration the magnitude of the area indicated in question 1.3.1. So the formula for area, we have a is equals to the integral from a to b of f of x dx. So we have to also shade the area. So let's shade the area. So we know that our from -1 to +1, so our limit, so a will be equals to the smaller number, which is equals to -1, and b will be the larger number, which is equals to +1. And our f of x is equals to 2 times e to the power x dx. So we can write this as, so we can decide to take the 2 out of the integral. So the integral of e to the power x, so we have 2 times the integral of e to the power x is equals to e to the power x, also available on the formula sheet. And our boundaries are from -1 to +1. So our area will be equals to 2 multiplied by, so we substitute the 1 and the -1 in the place of x. We start with the bigger number, x is equals to 1. So where there is x, we substitute 1, minus e to the power -1. So where there is x, now we substitute -1. And this will be equals to, so our area will be equals to 4,701. And since area is calculated in centimeter square or millimeter square, in this case we are not given any SI units, so we'll just use u squared. So u for unit squared. So this will be our answer for question 1.3.2.